welcome to lesson 3A-2, factoring using the GCF method. Our learning target for this lesson is that I can factor the GCF from a polynomial. And just a reminder, GCF stands for greatest common factor. So before we get started, we do have a little vocabulary for you to add to your glossary. Our vocabulary word for this lesson is complete factorization over the integers. Alright, so it has a long, complicated definition that we'll go over real quickly, and then when we actually start practicing this, you'll get to see kind of this definition in action. So our definition is going to be that the complete factorization over the integers is when we are writing a polynomial as a product of polynomials so that none of the factors is the number 1, that there is at most one factor of degree 0, each polynomial factor has degrees less than or equal to the degree of the product polynomial. Each polynomial factor has all integer coefficients, and none of the factor polynomial can be written as such a product. So go ahead and pause the video. I know that's a little bit lengthy definition, but we want to make sure we have that copied down into our glossary. When you have done that, go ahead and resume the video, and we'll pick up with the notes. Alright. So, want to do a quick review about factors. When we talked in Unit 1 about factors, we spent just a little bit of time on it, but now we're going to spend a lot more time on it when we look at these examples here. So just a reminder, if we were given the expression 4x squared y, we want to break it up into each thing that we're multiplying by. So our 4 would be one factor, x squared would be another, and y would be our third factor. We also looked at some in Unit 1 where we were multiplying a binomial times a binomial. In this case, we have x minus 2 times the quantity x plus 3. Each one of those would be a factor, and we can see them listed here. So we want to try. We want to look at what the factors of negative 2 and x squared is. So the factors of negative 2 and x squared, the two things that we're multiplying together, is negative 2 and x squared. Alright, if we look at the next one, where we have the three pieces there, we're going to have a factor of x, a factor of x minus 1, and a factor of 2x plus 3. So when we are looking at factoring using the greatest common factor, we're going to be looking at a polynomial, and we're going to try and figure out what the highest factor or the greatest factor is that we can factor out of each piece of it. So let's go ahead and go on. So we say that factoring is the process of breaking down algebraic expressions into the most simplified form of all its factors. What our whole goal in factoring is to break things down into smaller, more manageable pieces. And when we get to the end of Unit 3A, we're going to use those small pieces to actually help us solve equations that are a little bit more complex than the ones we were doing in Unit 2. In Unit 2, we limited everything to something with a degree 1. We had x's and y's, but we never get into anything that was x squared. That's what we're going to get to do at the end of this lesson. Or not at the end of this lesson, but at the end of this unit. Now, there are many strategies to factoring, and we're going to learn several of them in this unit. The next several lessons are going to focus on a different strategy. But this particular strategy, factoring using the GCF, is going to be something we're always going to look for. So we're always going to look for a GCF. We're going to look for anything that we can pull out that they have in common. And we're going to factor that out before proceeding with any of the other strategies. So this is kind of like a pre-strategy that we want to use before we get into any of the other methods in later lessons. And we'll go over those with you when we get there. Alright, so we want to go ahead and look at an example now. So we're asked to factor 2x plus 6x squared. So our first step in these is going to find the greatest common factor of all terms. This is what we were doing in lesson 3A1. So I'm going to look at my expression. I have 2x plus 6x squared. I'm going to break it down so that I can figure out what my factors are. Now a 2 breaks down into 2 times 1. So I have 2 times 1. I also have that x that I'm multiplying by. When I break this down, 6 is going to break down into 3 times 2. And x squared is going to break down into x times x. So if I'm looking for my common factors, I have a 2 here, I have a 2 here, I have an x here, and I have an x here. So my greatest common factor is going to be 2x. So my second step when I'm factoring using the GCF is going to be write my greatest common factor out to the side here, and then I'm going to put a set of parentheses. Now, to find out what goes in the parentheses, you can divide each term by the greatest common factor. So we are dividing each of these terms by the greatest common factor. If we divide 2x by 2x, our 2's are going to divide and give us 1. And our x's are going to divide and give us 1. So we're just going to have a 1 in this slot right here. Now if I do 6x squared divided by our greatest common factor, 6 divided by 2 is 3, and an x squared divided by an x, if you remember our exponent rules from lesson unit 1, lesson 7 I believe it was, we subtract those exponents. So 2 minus 1 is 1, so I would have a 3x. Now I put my 2x as my greatest common factor, that's going to stay outside, and I have my factored form. If you are struggling with thinking about dividing these, and you have broken down your factor tree like this, you'll also notice that the numbers we're putting inside here are the factors that we did not circle in the greatest common factor. For example, in 2x, we did not have a 1 as a common factor, and we ended up with a 1 here. With the 6x squared, we did not use the 3 or the other x in making our greatest common factor. So in that case, we had the 3x on the line. Either method of this works as long as you have done your complete factorization up here. So whichever strategy you find most helpful is the best strategy for you. Alright, let's look at some more examples. So we want to factor these examples. So we want to figure out what our greatest common factor is first. So if I break down 12, I could break that down into 6 times 2, and that's going to break down into 3 times 2, and my a's are going to break down to be a's, and a squared breaks down to a and a. With the 18, I'm going to break it down into 6 and 3, and that's going to break down the 6 into 2 and 3, and my a will come down here. So if I write out my factors so that it's a little bit easier to read, for my 12a squared, I had 3 times 2 times 2 times a times a. And for my 18a, I'm going to have a 2, a 3, a 3, and an a. So if I'm looking for my common factors, I have a 3 in each one, I have a 2 in each one, I have an a in each one. So my greatest common factor, I'm going to multiply those together. 3 times 2 times a is going to give me 6a. So I'm going to factor out a 6a, and I'm going to look at what it leaves me with. On the left, I'm going to have 2a. Now, we notice we have a negative sign in the middle. We want to make sure we keep that subtraction sign. Alright, and then the term that was not used here, the factor that was not used here, was a 3. So we're going to break this down, and we have our factored form, 6a times the quantity, 2a minus 3. Alright, let's move over to example 3. Now, one thing when we're factoring is we want to go from our highest term to our lowest term in terms of the variable. So if I have a variable first, I'm going to want to rewrite that as 25m minus 15. All I did was I kept the signs that we had, I just switched the order, and we can do that because addition is commutative. Now I do want to make sure that negative stays with the 15, so it does actually become a subtraction problem, but this is going to still be equivalent. Now that I've done that, I want to pull things out. Now sometimes you can probably go ahead and tell what the greatest common factor is going to be. For example, in 25 and 15, it's pretty easy to see that 5 is going to be the easiest number to pull out. 5 goes into 25 5 times. Now we didn't have any variables to pull out this time, so that m is going to stay. Alright, now remember we moved this so this was a subtraction sign now. And if we do negative 15 divided by 5, we're going to get that negative 3. So we have that factored out. Alright, in our next example, we have a trinomial. And these trinomials are going to be what you're going to predominantly see when we're factoring. You're going to probably, most typically, see 3 terms that we're going to have to factor. So let's go ahead and take a look at what we can factor out. Now I'm going to immediately notice that I have an x cubed, an x squared, and an x. So I know I'm going to be able to pull out one x from everything. This one only has one x to give, this has two x's to give, and that has three x's to give. So our greatest common factor is going to be an x. Now we have to figure out what our coefficient on that factor is going to be. So if I break down 4, 4 is going to break down into 2 times 2, which is pretty simple. 24 is going to break down, we could do 6 times 4, and the 4 is going to break into 2 times 2, and 3 times 2. And 12 can break down into 4 times 3, and 4 is going to break down into 2 times 2. So if I'm looking for my common factors, I have a 2 in everything. Now I remember I have to check all 3 terms. I have another 2 in everything. And that's going to be it. I do have a 3 in this one, and I do have a 3 in this one. But because I don't have a 3 in the first term, I'm not going to be able to pull that out. So I'm pulling out a 2 times 2, which is going to give me 4. Now, notice that nothing's left when I factored this one of my numbers, but I am going to have 2 of those x's left, so I'm going to have x squared. Now, I want to keep my sign, and when I factored the 24, I end up with a 3 times 2, which is 6. Now, x squared, I took out one of the x's, so I'm going to have x here. I want to keep my plus sign, and when I factored out here, I had a 3x left. So I end up with this completed fraction form. Not fraction, factored form, sorry. Alright, sometimes we might see some problems with different letters thrown in. Alright, notice here we're going to have x's and y's. Now, in this one, I'm going to go ahead and start out with the numbers, breaking them down. I have a 3 times 3. And I could do 3 times 9, and that 9 is going to break down into 3 times 3. Now, when you have multiple variables, it might be helpful to list them out, like we had been doing in the first example. I have 2 x's and 1 y. I'm just going to draw a little line here to separate those so we can keep them straight. Over here, I'm going to have an x, and I'm going to have 2 y's. So if I'm looking at what I can pull out, I have a 3 in this one, and a 3 in this one. I have a 3 in this one, and I have a 3 in this one. I have 1x here, I have 1x here. I have 1y here, and 1y. So if I pull each of those out, I am pulling out a 3 times 3, which is 9. And I'm also pulling out an x and a y. Now what I'm left over with, I have just that lonely x left there. And over here I have a 3y. Again, I want to make sure I keep that same sign. So since it was a subtraction there, I'm going to subtract here. And I'm left with the 3y. So I have my factored form here. Alright, just so that I can get a better view at my last 2 examples, I'm just going to erase a little bit here so that I can see that clearly. If you need to see what that was and didn't get copied down, you can go ahead and rewind it, and you should be able to see that just a few seconds before I erased it. But let's look at example 6. Now in example 6, we have a negative in front of our coefficient. Now one thing that we tend to do with factoring is we don't like having a leading coefficient that's negative. So what I am going to do is before I do anything else, I'm just going to factor out a negative 1 from everything. That way I change that first constant, or that first coefficient, to be positive. So I'm going to factor out a negative 1. Now, taking a -1 means we're going to divide everything by -1. And remember, dividing everything by -1 is going to do nothing but change the sign. So my -3x squared is going to become a positive 3x squared. My -7x will become a positive 7x. And my -9 will become a positive 9. Now, when I break this down, I still want to look to see if I have any other greatest common factors. So I'm just going to stick that -1 out to the front so I don't forget about it. I'm actually going to move it down just a little bit so I have some room to do some work. Alright, if I'm going to factor these, this is going to break down into 3 times 1 times x times x. Over here I'm going to have 7 times 1 times x. Over here I'm going to have 3 times 3. Now if you notice, I don't have any common factors this time. I have an x here and an x here, but I'm missing an x over here. I have a 3 in the first one, and I have a 3 in the last one, but I don't have a 3 in the middle. So we're going to see that this one actually does not have a greatest common factor. So if we were asked to factor that completely, we would just leave it by 3x squared plus 7x plus 9. Alright, we have one more example. Now example 7 is a little similar to example 3. We always want that variable to be our leader here. So I'm going to rewrite this. Now when I move the order, remember my signs have to stay together. So when I move this 7x, that -7x, I have to make sure that negative sign comes with it. Now this is a positive 49, so I'm going to add the 49. Alright, now we end up with the same situation. We don't want a leading coefficient that is negative. So we're going to go ahead and pull out a -1. And that's going to change our signs to give us a positive 7x and a -49. Now, just from knowing our multiplication facts, we know that 7 goes into 49. So, since 7 goes into both 7 and 49, we can pull out that 7. Now, what we're going to want to do with that 7 is multiply it by that -1 that's in front of it. So, I'm going to have 7 times -1. Now when I pull out 7 from 7x, I'm just going to have the x left. And when I pull out 7 from -49, I'm going to have a -7. So I do my 7 times -1 and get -7. And I can't do anything to simplify the x minus 7. So I have my complete factored form here. Alright, just a reminder, there is no application for 3A-2. Complete your practice and go ahead and begin preparing for your mastery check. We'll see you in the next video.